Hello, boys and girls. Now we're going to go over the math for this packet. This math is still having to do with fractions. Today's math goes over comparing fractions, putting fractions on number lines, and telling which fractions are larger than others. So let's look at that now. I'm starting on the page that says Lesson 11 Problem Set. It's page 149 on the bottom. So it gives us a tape diagram that's broken up into fourths, and it wants us to write the fractions that go with each of the different parts. So here is 0 on my number line, or where the fraction 0 would be. Then as I move over here, remember these are fourths, so this is 1/4, and I just keep counting up. 2/4, 3/4, and they've already done 4/4 for me, which remember is equal to 1/2. Whenever the top and bottom are the same, that is when we have 1/2. And then they want us to circle the fraction that labels the point on the number line that also names the shaded part of the tape diagram. So I'm going to circle 1/4 because that's how much is shaded. 1/4 of the entire tape diagram, or of the number line. Okay, now we're going to do the same thing for part B. So I'm going to look at how many total pieces I have. I have 1, 2, 3, 4, 5, 6, 7, 8. So since there are 8 pieces, I know that the last piece is going to be 8/8 or 1/2. Now I just need to label the rest, counting up to 8. So over here I have 0, then 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and finally 8/8 or 1/2. And now I need to circle the amount that's shaded. There are 2/8 that are shaded. I'm going to answer these questions over here. Take notice, are the units getting larger or smaller? Okay, so let's look at the pieces here compared to A. Are the pieces bigger or smaller? They are smaller. Whenever I have a bigger number in the denominator or on the bottom, that means that I have more pieces, and the more pieces I've broken it up into, the smaller the pieces are. It's like if you had a pizza and you broke it up into 10 pieces, or you broke it up into 100 pieces. The more pieces you have, the more people you're sharing it with, the smaller those pieces are going to be. Are the gray parts in both A and B equivalent? Well, let's look at them. Do they look like they line up? Yes, so they are equivalent. It's the same amount shaded here as here. So 1/4 is actually an equal fraction to 2/8. Okay? We're going to do the same thing here one more time. Let's count all our pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 this time. So this is 12/12. Again, I start at 0 and I count all the way up. Need to write a little small on this one because there are a bunch of pieces. Okay, so this part here is proving that 1/4 is equivalent to 2/8, which are our two fractions from up here. And they do that by multiplying the top and the bottom by 2. We've talked about before that if you multiply the numerator and the denominator by the same number, that gives you an equivalent fraction every time. So 1 times 2 is 2, 4 times 2 is 8. That proves that they're equivalent. And why are we multiplying by 2/2? Well, remember, when the numerator and denominator are the same, that means it's equal to 1/2. So we're really multiplying that by 1/2. And if I multiply anything by 1, I get the same number back. So multiplying any fraction by 1/2 gives me an equal fraction. Here we have something that's very similar, except now we need to draw our own number line to go with the tape diagram. So I'm going to draw my number line here. They've already done part A for us. And I'm going to put a tick mark to line up with every section of the diagram. And then I'm going to count how many pieces I have. So here I have 1, 2, 3, 4, 5, 6 total pieces. So on this side I have 6/6 or 1/2. And then I'm just going to count up, labeling each of my pieces. So 0, 1/6, 2/6, 3/6, 4/6, 5/6, all the way up to 6/6. And then I'm going to look at how many are shaded and circle that number. So I have 1, 2, 3, 4, 6 that are shaded. So that is what I circle. I'm going to do the same thing for part C, counting my pieces. Here I have 12 pieces. So over here I have 12 12s, and then I will label all of these all the way down. Going to have to write kind of small to fit all of the numbers. And I look at how many are shaded. 8 12s are shaded. Down here it says the fraction represented in 3a, which is 2/3, is equivalent to the fraction in 3b, which is 4/6. And they've used division to show us that those are equal. They divided both parts by 2, which gives us an equivalent fraction. Okay, at part B, it says the fraction represented in 3a, which is 2/3, is equivalent to the fraction in 3c, which is 8 12s. And again, I'm going to use division to show that. So I'm going to divide 8 and 12 both by the same number. So I ask myself, what can I divide 8 by to get 2? Well, I can divide it by 4 because 4 times 2 is 8. And same thing with the 12, I divide it by 4 and that gives me 3. So that proves to me that 8 12ths is equivalent to 2/3 because I divide both the top and bottom numbers by the same number, and that shows me they're equivalent. Okay, looking at the next page. Here they have not given me a tape diagram or a number line, so I need to draw it all myself. It says partition a number line from 0 to 1 into fifths. So I'm going to have a number line, and it's going to be broken into fifths. So I start with 0. I count all the way up to 5/5 or 1 whole. Then it tells me to decompose 2/5 into 4 equal pieces. So right now, here is 2/5. I'm going to cover up the rest of the number line. That's 2 pieces, 2/5. I want it to be 4 pieces. So I'm going to break each of those pieces in half. So now I have 1, 2, 3, 4 equal pieces there. I think it also helps to draw a tape diagram to go with this. You don't have to do that, but I'm going to go ahead and do it because I think it helps. So I started out with fifths, there's my fifths, and then I broke these 2 pieces in half to make 4 equal pieces there. Write a number sentence using multiplication to show what fraction represented on the number line is equivalent to 2/5. So here by splitting it up, we've made a new fraction. I'm going to go ahead and split all of these in half so that we can see what our new denominator is. So now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces. And I look at how many are shaded to get my top number. So 4 are shaded, so my new fraction is 4/10. The fraction before was 2/5. They want us to use multiplication to show that these are equivalent. So I ask myself, 2 times what gives me 4? That is 2. And 5 times 2 gives me 10. So since I'm multiplying them both by the same number, that proves that they're equivalent. Now they want me to do the same thing but using division to show they're equivalent. So all I'm going to do is use these same 2 numbers but swap their position. So I'm going to start with the larger number, and now I'm going to divide. So what can I divide 4 by to get to 2? Again, my answer is 2. 10 divided by 2 is 5. So you'll notice a pattern here. First I multiplied by 2, now I divide by 2. It's just the inverse operation. Okay, this is exactly the same down here. It says partition a number line from 0 to 1 into fourths, decompose 3/4. So again, I'm going to draw a number line and I'm going to break it into fourths, and then I'm going to break up 3/4. I'm going to go ahead and do this with you. If you already feel like you know how to do this, you can pause the video and do it on your own, or fast forward if you would like. So I have 4 pieces. I'm going to break my tape diagram into fourths and my number line into fourths. Going to label my pieces. And I'm going to go ahead and shade in 3/4. Then it tells me to decompose 3/4. So when I decompose, I break apart. So I'm going to go ahead and break each of these pieces in half to decompose it. I could break it into more pieces if I wanted to, but to keep it simple, I'm just going to break them all in half. Okay, down here it says, write a number sentence using multiplication to show what fraction represented on the number line is equivalent to 3/4. So this is the same thing we did up here. I'm going to look at my new fraction. I have 1, 2, 3, 4, 5, 6 eighths shaded now, and the fraction I started with was 3/4. And I'm going to multiply to prove that they're equivalent. If I can multiply them both by the same number, then they are equivalent. 3 times what is 6? Well, I know that's 2, and 4 times 2 is 8. So they are equal or equivalent. Okay, this next page is more of the same. I'm not going to do this one with you, but again, you're going to draw the number line, break it up into sixths, and then break up 2 sixths into smaller pieces so that you have 4 equal pieces. Then you'll write a multiplication and a division sentence to prove that they're equivalent. For number 8, it wants you to explain using a model or words what happens to the units when you multiply a fraction by another fraction. Okay, let's look at an example to think about this one. So if I start with 1/4 and I multiply it by 2/2 or 1 whole, then I end up with 2/8. So what has happened to the amount of units here? Well, it went from fourths to eighths. So I have more units. But what happens to the size of the units from fourths to eighths? Well, fourths are bigger than eighths. Even though we think of 8 as a bigger number, if I'm sharing a pizza with 7 other people, I'm going to get less pizza than if I was sharing it with only 3 other people, splitting it up into fourths. So I have more units, but the size is smaller. And then for number 9, it wants us to do the opposite. Explain using a model or words what happens to the units when you divide a fraction by another fraction. So let's take the same example, but now let's divide. So 2/8 divided by 2, that would give me 1/4. So now I have less units. My number is smaller, but the size of the units is bigger. So I have the opposite thing happening when I'm dividing than when I'm multiplying, which makes sense because they're inverse operations. Okay, let's look at the next page. They have very kindly done this first part for us. So they put these 3 fractions on the number line. So we see 0 over here, 1/2, then we have 7/12, which is just barely larger than 1/2, 5/6, and 1 whole. So now I'm going to use that number line to help me compare these fractions. So which is larger, 7/12 or 1/2? Well, I can look at my number line. 7/12 is just a little bit closer to 1 whole than 1/2 is. So that shows me that 7/12 is larger. What about 7/12 and 5/6? Well, again, if I look, here's 7/12, here's 5/6. 5/6 is closer to 1 whole, so that shows me that 5/6 is larger. Let's do 11 together. Now we need to put these three fractions on the number line ourselves. So when I'm doing this, I like to look at the fractions and ask myself how close they are to 1 whole or 1/2, and that helps me to place them. So 11/12, that is really close to 1 whole. And how do I know that? Well, remember when the top and bottom numbers are the same, that's 1 whole. So 12/12 would be 1 whole. 11/12 is really close to that. So I'm going to draw 11/12 right here, right by 1 whole. So we're done with that one. Now let's do 1/4. Where does 1/4 go? Is that more or less than 1/2? Well, if you're not sure, you can always draw a picture to help you. So here is what 1/2 would look like. And here is what 1/4 would look like. So which is bigger? 1/2 is bigger. So I'm going to put 1/4 over here. And then I have 3/8. Again, I could draw a picture of it if I wasn't sure, but I know that 4/8 is 1/2 because 4 is half of 8. So 3/8 is just a little bit less than 1/2. So that's what my number line should look like. Then for part B, it says select two fractions from part A and use the given number line to compare them by writing less than, greater than, or equal to. So I'm going to choose any two of these fractions to compare. Let's do 1/4 and 11/12. Well, I can very easily look at my number line and see that 11/12 is a lot larger than 1/4. C says explain how you plotted the points in part A. So you're going to explain that in your own words. What did you do? You might say that you compared the fractions to 1 whole or to 1/2, or that you looked at how close the numerator was to the denominator. I want you to explain there in your own words how you did that part. On the next page, where it says lesson 12 problem set, we are now comparing two fractions. We no longer need to draw a number line. Though if it helps you, you can always draw a number line if you want in some of this empty space. And then you need to somehow prove how you knew which one was larger or that they were equal. Up here, they did the first two for you and they explained it in words. You could do it that way, or you could also do the butterfly method. I know that you all are big fans of the butterfly method, so I'm going to review for you how we did that. So I draw my butterfly wings, and on this side I do 3 times 2, which gives me 6. And on this side I do 5 times 2, which gives me 10. And I look at which side gives me a larger result. Well, 10 is larger than 6, so that shows me that 2/3 is greater than 2/5. Let me show you that one more time for part D. So I multiply 9 by 5, which is 45. And 3 times 10, which is 30. 45 is larger than 30, so 9/10 is larger than 3/5. You can do the same thing for the rest of the page. Again, if you want to use another method, you are more than welcome to, but you need to make sure you're showing your work or explaining how you got your answer in some way. The rest of this packet is just like other pages that we've done. The lesson 12 homework is exactly the same as that previous page, saying which one is larger and giving an example or showing your work for how you know. Lesson 13 problem set is putting the fractions on the number line and saying which ones are larger, using that number line to help you. And then there is another page of comparing. So you should know how to do all of those pages, and if you forget, you can look back at some of those examples we just did. The last 2 pages in the packet are these templates, and these are just for you to use if you need to help you to compare fractions. So if it helps you to draw them on the number line, you are more than welcome to use these as an extra resource for yourself. So that is it for the math for this week of the packet. I want to say thank you to all the parents watching for all that you've done for your kids throughout the year and especially in these last 2 months. I know that it has not been easy for many of you to juggle work and all the things you normally do while also trying to help your kids with schoolwork. So thank you so much for the efforts that you've made. They have made a difference. I also want to thank all of the boys and girls for the great school year that we had this year. I miss all of you, I love you, and I'm looking forward to seeing you in the fall. Bye.